Hello there. Today we'll be talking about using 3D toolpaths, or more accurately, abusing 3D toolpaths in order to make your cam way faster. Okay, so first of all, I should preface this by saying that this technique can work for HSM works for SolidWorks and HSM works for Inventor as well as Fusion, because they're all powered off the same engine anyway. They might not work exactly as well on SolidWorks, just because SolidWorks HSM works is kind of dumb, but I mean it works fine in Fusion. So if you do use Fusion, this is a very good technique. So anyway, let's get right to it. So for example, let's say we have this here plate, right? So we've got a series of gussets here that we need to cut out. Okay, and I've just put some random holes in these just so you can see what it looks like when you have to pocket something. Okay, this is a pretty common problem. So I've got my plates, I've got them all assembled in the layout I kind of want, or I've imported them from somewhere like some nesting software, and now I'm like, well, I want to cam it. Well, traditionally, what you do is let's say I have a template set up already, just because I'm lazy. So first of all, I'll make my setup here. No additional stock is what I normally do. Change my orientation so I can actually do things properly. And select a stock point over here. Alright, so we have them set up. Now I'm going to create from template. And for example, CGSV2 is the one that 1072 is using right now. And you can see we've got a few different tools here and a few different operations, okay? And so, well, first of all, let's say we have a drill, okay? So this is going to be our spot drill, so I'll select all those holes and all those holes and all these holes and all these holes. Fine. Alright, and then this one I got to select the 0.196 holes. So let's see if I can't, yeah, that's all those. Alright. And now I need the 0.159 holes, which I think are these. Yeah, there you go. Then I do an adaptive, and I gotta click on all these in order to make sure that my adaptive goes through properly. Yeah. Okay. Then you go to the 2D contour, and I gotta contour everything on my pockets, right? So that's those three right there. Then go to this contour and select all the outside contours. And finally, after much effort, oops. Hit OK. And there we are. So we got a spot drill, regular drilling. We got our adaptive clear, finish that up with the contour, then go for another contour. Now, that took unbearably long. To me, personally, that took like 2 minutes. Okay, that's too long. And I got to inspect all these toolpaths as well afterwards. Honestly, it's just too much work for me. And also all the tool changes between these tools, you can miss me with that. Okay, look at this. There's like 3 or 4 tool changes here. That's like an easy 2 minutes that we've lost. This entire job takes me 32 minutes. Losing 2 minutes isn't awful, actually, for a 32-minute job, but I can definitely make this faster than 32 minutes, especially if I'm doing this on a CNC router. These are designed to be done on a CNC mill, which means that our drilling isn't going to be that fast, and also that our adaptives and contours and stuff aren't quite as efficient as we could get with a high-speed CNC router. So, with that in mind, let's go ahead and think about camming this in the cool way. And the cool way is to use 3D tools. So I've already got a template for this, but I'll walk through and explain how it does. Basically, let's say we take a 3D test over here. All right, we do a pocket. So for pocket, we just select all of our contours there. And it'd be nice if I set this up automatically as a macro, so that way when I select like these pockets, I don't have to reselect them for the other contour. Yeah, I can run that warning right there. This contour here is going to do the finishing passes. And I still didn't have that 2D contour for the cutout, but the important part is that I can basically do most of this with just the pocket and the contour op. So, for example, right here, contour finds all the holes, does a boring operation on all of the holes, or sorry, pocket will do a boring operation on all the holes, and it'll do a swirly kind of more spiral pocket over here, which is fine. I don't really need an adaptive clear for this, and this is probably faster as well for a lot of pockets because I don't have a lot of time, but I'm just doing rapid moves in air. And for a router, most of what you're doing already is slotting. And in this case, because it's all 1/8" material, I'm definitely slotting like all of this. And the contour is just going to go in there and finish all these up. Real straightforward. Takes just however long it takes for you to click on all the parts in your program. And you can even do it faster than that if you find a way to optimize the way you're selecting stuff. You can actually do it a little bit faster, which I like a lot. So if I simulate this, this takes, 9 minutes now. So first of all, that's already quite fast. And then if I want to add on the, let me add on the thing here. CGSV2. I'm going to go ahead and delete all of these except for the last one. Change this tool to the one that I already have open. We'll go over here. Right there, my trusty 4x12 Hu-Hao end mill, cutting at 48 inches a minute now that I've received confirmation that we can, yes, that's right, we can slot at 50 inches a minute with these things, which is great. Cut the next 0.04, oops, right, I need to select my contours, don't I? And make sure that you select all of the external contours there. So, here we are. And there you go. So total, this job now takes me 22 minutes and no tool changes either. So it's really more like 20 minutes compared to the other one's 32. So I'm doing way faster for these kinds of gussets on the router right now. And it took me almost no time to do the cam for these. And you'll notice for these, I got a very, very tight spiral because this is the 0.159 hole, and I'm going to be machining it with a 0.157 end mill. Really, 0.152 is what or 0.153 is what I have it in Fusion, but it really is a 0.157 end mill. So this is a very tight spiral in order to get in there. You can see that. But that's good, because that tight spiral has been taking at 40 inches a minute, which means that my effective feed rate there, in terms of like going straight down, is very slow. You see that? It's a very slow kind of plunge, a very slow kind of bore that it's doing. Maybe only like 1/100 of an inch, again right there. It's basically just vibrating as it goes down. So even though it looks like it takes a while, it's not taking that long, and also it's doing a very good job on those holes, making sure that it doesn't overload the end mill by taking too deep of a ramp or just plunging either. So, yeah. Now, you may ask, how do I set up this magic? Well, it's pretty straightforward. So, first of all, you're going to want to use the 3D pocket clearing. You can use adaptive clearing. Don't get me wrong, adaptive clearing is great. It has its place. But in FRC, I used to be a big fan of adaptive clearing because it is kind of like the future, but when it comes to routers, it's not really that relevant. Pocket clearing is actually just faster taking out the material because you're not wasting so much time on rapids. And the thing is, when you're using a router, you're doing very, very high feed rates, just like an adaptive clear likes, of course, but you're also oftentimes able to just slot because you're using one fluid end mills. There's really no reason to do an adaptive clear when you can just go ahead and slot it. If you're working with a thicker material, like 3/8 inch or 1/2 inch thick material that you can't take in one pass, even 1/4 inch material, you can't take it in one pass, right? Then it's time to start talking about adaptive clearing. But for these kinds of 1/8 inch plates, I'm totally fine with just a regular old pocket. And even for those deeper things, using morphed spiral machining, which kind of just makes a curvy pocket instead of a straight edged pocket, does a great job of making sure that this actually comes out nice. Big fan of that. I don't have a minimum cutting radius set on this. I should probably set that up to be like 0.015. Get an automatic little fillet in there, right? I've got very low tolerance. I think the default is quite high, so I set those to 2/10,000ths. I've set a very large maximum roughing step down. I have no idea why I did that. That should be smaller, but that doesn't matter. You can adjust this based on what kind of stock you have if you really care that much. In this case, I'm actually going to set this to 0.15 or 1/8 because that way I can take this in 2 passes if it's 3/16. All right, great. We also got helical ramp, 4 degrees, 0.3 inch maximum step down, a low clearance height. You'll notice the safe distance is pretty short, and that's probably why I got an error on this last time. Because safe distance is basically defining how far above the stock to start your pockets. So like it's the height of this, and especially on thicker plates like this one, that tends to get screwed up because you don't need to go like a 1/2 inch up every time. You only need to go a little bit up. It's just that the step screws it up. You'll see. We'll do this one in just a second. But anyway, pocket is pretty straightforward. So you select your thing, you do tool center on boundary. Usually that works fine. You have to do selection. If you do silhouette will exclude these holes from being machined, but it won't. So it'll exclude 3 holes from being machined, meaning that it won't machine anything, which makes it useless. Now heights is interesting. I have an offset from the model top and an offset from the model bottom for my stuff. Now why is that? That's because if you do a 0 offset from the model top, it'll try to face down the top of each plate, which doesn't make sense. So if I set this to 0, let's see if it does it this time. If I set this to 0, it'll take a second to generate. And by a second, I mean like a minute. And when it does, you see that? That's worthless. I don't need to do this. And this takes like, Jesus Christ, 30 minutes right there just for that. This, like, altogether, this will take 44 minutes, almost doubling the amount of time. So you have to have a negative offset from the model top. Now you might think this is dangerous, right? Because, like, you know, what if the end mill is trying to go to 0 and it just skims 5,000ths in? Well, your end mill should never go to 0, okay? Like, it should always be at the retract height or the clearance height before and after the operation. So this is pretty safe. This is pretty much negligible. For passes, again, I've set my high tolerances here, or low tolerances, depending on how you define it. It's very small minimum diameter I'm allowing it to do, so anything larger than the end mill, basically, is what it's allowed to machine. I do have a minimum cutting radius set, but I just realized why I have none set. That's because I want to be able to get into these very small holes. So I don't think that is 0. If you have no tapped holes, you can probably set this higher than 0, but in my case, I have tapped holes here. 1032 tapped holes with a 4mm end mill. I can't really afford to have a radius on that. Sorry. I can do like a 2000th radius, 1000th radius. That's it. Flat area detection just detects flat areas and machines down to them. Basically what we want. Yeah, basically. I can disable it and it'll automatically just go down to straight to the bottom for each of these. If I do this right, yeah, there you go. So it'll automatically machine to the bottom level. Not bad if you want to cut through a plate all the time. Bad if you want to cut to a specific depth, and we'll see more about that in a second here. So I'll leave that on for now. All this other stuff is just normal, smoothing, you know, stock to leave, all this stuff the same. Linking as usual is, you know, nomic and hard to understand, but the point is I have a very small lead out radius, just because I'm doing, and there's really no reason not to have a small lead out radius on this, to be quite honest. It's just to basically exit from these smaller holes without leaving a gouge. These can stay pretty much the same. Save distance should be set low. If you set it too high, then it will lift up quite far. 40 ramp works fine. Low ramp clearance height, small helical ramp diameter, and a very small minimum ramp diameter to deal with those tiny 0.159 holes. Hit OK, regenerate. Contour, pretty much same options. You do by selection, tool center on boundary. You select all your contours. It'll automatically detect any contours inside of there and do those. Same thing, I have an offset from the stock top and the bottom. Passes, I have a high maximum step down because I want to be able to take the whole thing. This is finishing pass right here. This is basically like a skim cut. Because on the pocket, I actually leave no stock here. I have no stock to leave checked. So this contour is quite literally just a skim cut meant to take off any remaining material. Clean up those bearing pockets mainly. The main difference between this one and the pocket is the way I have this set up here. I have an actual horizontal lead-in radius and an actual vertical lead-in radius. And I have an actual minimum diameter set. Mainly it's minimum diameter is doing the job here, but the minimum diameter basically just guarantees I'm not going to try and finish all of these tiny holes. If you want to finish those tiny holes, feel free to set this smaller. But I don't want to, so I'm not going to. So this works fine. And remember, I don't need to actually set any of this. After the first time I set this up, I can just click on it and it'll do my stuff. And if you're paranoid, you can have multiple templates for each plate thickness that you work with. Like say, one for 1/8 and 1/16, one for 3/16 and quarter, or one for 3/16 and one for quarter. That's it. I mean, for FRC, you don't really need more than that. And you need 2x1, of course. And my regular 2D contour at the bottom. This is just regular 2D contour. I've got a slight finishing pass there, as you can see, kind of. But yeah, I've got a finishing pass there. And this is just your bog standard thing. You know, you select your chains. I got tabs enabled right now, but tabs are weak. I'm not doing that right now because I'm using a router. Again, cut 0.04 through. Multiple depths, 0.07 each time. I'm just going to not do that. I am going to, however, have a finishing pass here. And because I'm doing an 1/8 inch depth of cut, I'm going to slow this feed rate down just a hair to like 40 inches a minute. And I can leave the rest of these pretty much alone. And a ramp angle of 5 degrees because I hate waiting forever on these freaking contours for them to go down. There's that. And I can set smaller, of course, why not? Apart from that, everything else is totally fine. I'm actually going to uncheck lead in because it's useless on these kinds of things because you're leading in above the part, so like you're not even cutting when you lead in. Literally not worth it. But I will keep these small radii here. And let's do a smaller step over for that finishing pass because I'm doing this on a router again. And on a router I have, I guess, not tighter tolerances, but more vibration, so I can take a smaller finishing pass and still get a result. So you can see that very small finishing pass. And there you go. We are set up. This total job takes me 16 minutes. Great. Very, very, very fast. For a thin sheet like this one, I'm actually doing it faster than we do on the CNC mill just because I have higher spindle RPMs and smaller end mill. So I'll go ahead and save this right here. And I'm actually going to store this as a template so I can show you how to do this. So I'm just going to say 3D test. Okay. Yes. Alright. Now I want to cam this. So, oh, why did it? Okay, there you go. Let's say I want to cam this guy, right? Same thing. Make a setup. We're going to define our z-axis plane and our x-axis there. And I want to have a stock box point, say over here, because I'm lazy, I don't want to flip anything. No additional stock. Hit OK. Create from template, 3D test, and from here, very easy. I just need to select one contour, which in this case has to be the bottom. If for example on the bottom it was like a like symmetric and I have this like shit up here, then I could just be like, okay, I want this contour and like this contour and this contour, and it'll machine all of those. But in this case we are blessed and the bottom is flat, so I can just do the one contour there. Same thing here, one contour there. Same thing here. This is gonna be the cutout, so one contour there. And most likely I'd want this one in a separate operation, but I'm lazy, and I should probably set multiple depths for this as well. 0.125. And there you go. Oh, and also finish only at final depth, because I don't want to finish at every single interval. Alright, and the time it took for me to set that one up, these are already done. And you can see that, really funky looking toolpath, but you can actually see it does do the counterbore there. It doesn't get into all these holes, but the reason for that is that these are tiny holes that are smaller than the end mill. They're like less than an 1/8 inch, so of course it's not going to get in there. This hole also less than an 1/8 inch, it's not going to get in there. This one is this is an 832 tap, so 0.136. This 832 clearance, 0.165. So it'll get in here, but not in here. But apart from that, it's doing everything very easily. It's doing, what kind of step down are we looking at here? We're looking at a step down of 0.18. I can't tell if this is actually 0.18. I'm gonna assume it is, because I have no way of telling, to be quite honest. I think it is, because this stuff is actually pretty thick material. So click here, hit simulate, hit play, and this is gonna take 34 minutes. Reasonable. It'll take a while, but it'll get done eventually. Skip all this stuff, let Fusion finally catch up to me, and eventually it'll start cutting again. There it is. And you can see that. It'll cut the counterbores, it'll cut out the pockets, cut out this thing and finish it. Everything is done. Beautiful. No problems at all. And unlike an adaptive clear where it leaves a really bad finish on the walls, pocketing and contouring afterwards will leave a very good finish on your walls. So if you're worried about that kind of thing, well, you're in luck. And you can see right at the end there, well, let's see if you can see that. Right at the end there, we do have a teeny tiny lead out right there. And that's just enough to stop us from gouging when we come out. Because otherwise, you leave this vertical tool mark right here, which is very noticeable and kind of annoying, actually. But if you have too much of a lead out, then you just bite like straight into like a 1/2 inch thick piece of plate with your 1/2 inch long end mill, and you're like, why did I do this to me? It's very sad. So anyway, that's that. And there you have it. It took me like a minute to set up this cam. I can just go straight to the machine after this, and I'm ready to go. Of course, after a quick simulation and inspection, it's maybe like 2 or 3 minutes, based on what I'm doing. But again, very fast, very optimized, just works. Sure beats the hell out of selecting every pocket individually for your 2D contour. Okay, like even if you don't use this, even if you want to use your adaptive clear and your 3D adaptive, whatever, this 2D contour is, you just can't beat it. It's so good. You can see here I am doing 2 contours. That's just because of the settings I have for this. I could probably force it to do 1 contour if I set the top height to be lower such that it lay below the top of here. But I don't really care. I'm totally fine with that not being a thing. Overall, this stock is 3/8 inch thick, so it's okay if I take 2 contours on this. It's not going to really make my finish suffer or anything like that. There you go. Last use cases, let's say we have this funky 2x1 here, right? And this is interesting, because here we have 3 through holes, okay? We've got a blind hole, or I guess like through one side hole, and a blind pocket. 2 blind pockets right here, one with the radius, one without. So this, traditionally, is actually not a very simple problem. Well, it is pretty simple if you know what you're doing. You'd go here to adaptive clearing, you'd maybe select this, you'd define your heights to be like from the top, otherwise it'll try to machine through all the way. And in a router, I don't have a 1 inch end mill loaded in and ready to go, so I'll only want to do 1/4 at a time, so let's say maybe 0.25 inch deep, right? And I'll do that negative. Okay. I need to select my end mill here. Again, my 4mm Hu Hao, because they're beautiful. And let's see if this actually generates. And you can see, of course, adaptive So slow. Takes so long. This is such a simple part, and it just is killing me. And there it is. Finally. And oh yeah, look at that. It's facing everything off because, once again, I have not set my top height correctly there. And if we're lucky, it actually will generate correctly this time. And there it is. Wow, amazing. And then I got to go back and contour those individually, and then do this thing and this thing. Like, no, just nah. We're not doing that. Instead, I got another template for you guys. 3D 2x1 test. Once again, well, this is interesting because in this one I have a pocket and a contour. The pocket is if you have blind pockets like this one. If you just use contour, which is doable, I select my contour. Or actually, I don't even select my contour. Actually, none of that. I just hit edit and then I hit OK. And then it just generates. Because I have bounding box selected because it's just a rectangle. And there you go. You can see that. It'll just contour, right? No problemo, okay? Totally fine. Might even want to do even more of an offset from the model top for this one just to make sure I don't get that extra... I got it anyway. Sucks to be me. Still, spirals down, gets that crisp helical motion, and leads out at the end in a helix? I don't know what to put that, but it doesn't matter. Point is, it gets done. The problem is, if I simulate this, you'll quickly notice an issue with these here blind pockets. Alright, so it goes down. Okay, fine. You did good. Alright, comes down. Takes call, passes. Mills it out. Okay. Okay, bores that guy in. Fine. Alright. Alright, there's the puck dropping out right there. Alright, so hold up. What's all this? What's all this in the middle? What's going on here? So that's a problem right there. That is a problem right there. Really quickly, actually, I haven't tried this yet. If I set a minimum cutting radius of 0.006, does that stop it from doing these holes? Actually, that's not big enough. Let's say do a bigger radius there, like 0.05. Does that stop from doing those? Yeah. So if I do bigger radius, then it just won't do these holes, which is kind of a bummer because I was hoping I could avoid getting into sharp corners. But I guess that's not in the cards today. So fine. Anyway, now this is where 2D Pocket comes in. So right now I have rest machining enabled. I don't know why I have that enabled, to be quite honest. You can ignore that. That's just the thing the safe distances, maximum step down, are just bad. Don't worry about it. Alright, so there's the contour. Then the pocket generates from the contour, and you'll notice the contour will cut through here. And because this is a through hole, the pocket will assume this is done. But it won't assume this is done, because rest machining just looks at a top view, right? And then it says, okay, what is still left to be cut out? Well, not this is just empty air. But here is not empty air, so it'll try to pocket this out and then pocket these out. So it's kind of like, I'm not going to say worthless, it's kind of janky. And I really don't like it. So in this case, what I would do is if I had a lot of these blind pockets, I would just not use a contour. I just pocket the whole thing. And screw rest machining. And why isn't it cutting out that thing? Oh, because my model, this is set wrong. So this is interesting. Safe distance is basically just how long to lift up. That's just like, I don't know why they keep on giving me an error when this is too small. I don't really want to lift up 2 inches every time I do something. You know, it's not something personal. I just don't want to do that. Yeah, I still have not a clue why this is happening right here. I guess if you're really desperate, then you can just do contouring as a rest machining operation. That might do it. There you go. Now if I rearrange this pocket here and turn on rest machining for this guy, let's see what that does, shall we? So the pocket will do this as we expect, fine. And the contour will just do this, yeah. So you could do that. You can do contouring after the pocket as a rest machining operation, and the pocket will take care of your blind pockets of all sorts, and the contour will take care of anything that's actually through all, right there. That the pocket does not take care of. The pocket, for some reason, also takes care of this hole, and the contour doesn't go back for it. Don't ask me why. I don't really know. I also don't really care. It just works. This 2D contour is very straightforward. It's just where I want to cut off the tube, so if my stop is going to be on this side, I just say I Alt-click right here, hit OK, and this one will do my cutout operation. And I've specified this to go both ways, but I've also told it to do a finishing pass. So this one will go back and forth, plunge and come back. And the final pass it does will come back right here as a finishing pass. It's a climb milling operation, so it's very good. Anyway, that pretty much wraps up what I have to say about 3D Toolpaths. Bottom line is, once you set them up, 3D Toolpaths are great. So I'm actually going to save this over my old template because I know that this is better. So it's going to be 3D 2x1 test. Yes. And now, if I do any 2x1, I can just open it up and it'll be done. So, for example, let's say I want to do like some wacky thing here. Let's say I want to cut out these nuts. Huh, these nuts. Okay, but yeah, it's really kids will grow up. Anyway, I'm not going to delete these. I'm just going to make a new setup here. Come on. Come on. Let's make a new setup. Once again, I want no additional stock. Give me custom planes here. Just like that. Stock point. Corner, because it's easier for me to keep track of. Graven template. 3D test. Let's see if this works. Controls G. Alright. I did not select contours for this because I am big stupid. So let's go ahead and select these. And this is kind of bummer. You still have to select every single part. I don't like that. I think there should be a better way to do this. But there ain't. So sucks to suck. And this one, of course, you know, just your regular old contour there. Hey, is this on the wrong side? No, I haven't seen it in a long time. There you go. And yeah, stock bottom and all that. All right. And there you go. That's our contour right there. And this is looking a little aggressive here, just a hair. So I'm gonna go ahead and change that to a masset of an 1/8 inch. There you go. That looks much better. And of course, because once again, about to finish my final depth. There you go. Whole operation takes me 5 minutes. Seems reasonable to me. So pockets it out, goes to 2 depths because this is a pretty deep thing. This is a 1/4 inch thing here. Goes to the bottom, contours it once, then comes around and contours it out. Great. In this particular instance, I might actually want to use tabs because, like, you know, these are not held on by anything, and I have to put like 3 screws in the inside to hold them. Not impossible, but it's kind of dumb. So in this particular case, I might choose to use tabs. But anyway, bottom line is this thing is working pretty darn well. And if you have any questions about 3D stuff, you can direct them to me on my Chief Delphi, Acid61, or on Discord, Acid61, or on F4, Acid61, or in the comments, which is just me. So, yeah, go ahead. But yeah, 3D stuff is busted. And if you've been using 2D all your life, you can just get that out because it's not worth it. This kind of stuff, pocket clearing and contour, busted. It's the new meta. So I'll see you later.